Alright, welcome back to the Roblox course, and in this lecture we're going to actually look at Vector3 and positioning. So first of all, I have created a new script called Vector3 position here under our server script service. And I've also created a new part called position part, which is positioned at position 0 and 10 y and 10 to z. And we're actually going to play around with this a little bit. So first things first, when we select this part and we go down completely, we can actually see the size is 444. This is the first thing that we're going to change. So we're going to say part.size, and we're going to change this by giving it a new Vector3. Now, of course, a Vector3 simply means that it's three numbers, x, y, and z. And this should be fairly easily understandable. We have a direction x, we have a direction y, and a direction z. And the numbers of the size simply say, okay, it's this many, well, units in this direction, this many units size in this direction, and this many units size in the other direction. And we're going to create a new vector. How we do this is we write in vector3.new, and then we will type in the three coordinates, let's say. So let's make this a little bit bigger, so 8, 8, and 8. There you can see as a suggestion, we already have number x, y, and z. I'm going to say we're going to use this, and what should happen is that this should basically expand to 888, size 888. So let's spawn in and see what happens. So this is, it should be bigger, I believe. Let's select it and go down, and indeed it is 888. In 444, it would look like this. Sort of a Mario cube almost. But in 888, of course, it's a little bit bigger. So let's just relaunch this again and see. So the size has changed on this part. So this is the first thing that we can do with Vector3. Now we can also change the position. So this is once again simply part.position. And then we also say new vector, and then let's go with 10, 10, 10. So let's just move it about a little bit. Right now it is at 0, 10, 10. So we're gonna push it 10 points into the x direction, into the positive x direction, right? After this is being launched. So let's see, let's launch and let's see what happens. And as you can see, it is now no longer on this side, but on this side. And if we check here the position part, you can see 10, 10, 10 is the position, and 888 is the size. Now there are also plenty of things that we can do with vectors. So for example, after the theory, you should be able to think about this in, well, at least a little bit of terms. We can just take the position and add a new vector to it. So we can just add a new vector here. So for example, 5, 5, 5. This would then yield 15, 15, and 15, for example. We can, by the way, also do this by doing a plus equals. So this also works, right? So if we do vector3.new, 5, 5, 5, this also works. Right? So we can do both of those. I'm going to comment one of them out just for the sake of argument, but both of them work. And then let's see if we do this. Then we would expect this to be at 15, 15, 15. And let us look at position. And this is at 15, 15, and 15. Great. So something else that is possible, we can do part.size, for example. Once again, both of those are vectors, so you can have vector operations with them how you please. You can also do times equals. So let's say we want this 50% bigger, let's say. Then we would just times it by 1.5, and let's see how this works. This should yield a 12 size, if I'm not mistaken. And indeed, because 8 times 1.5 is 12, and it's going to be 12, 12, and 12. Now, what's very important, of course, these, of course, can be different numbers, right? This is just, maybe not the best way to show it. So we could just do something like that. Well, 31 is maybe a little bit much, then I have to walk a little bit too much. Let's say 14, and then let's say this can also be negative numbers, right? -4, 0, it could be 0, right? Something like that. So completely crazy numbers. Let's see what happens now. I'm not sure where it's going to be. Oh, it's going to be there. That's good. Right. So those, of course, don't have to be the same numbers. Right now it's 12 in the x direction, 3 in the y direction, and 7.5 in the z direction. And it is positioned at 5, 15, and 10 after all of those operations. There is one more thing I want to look at when it comes to vectors in themselves. So we've seen the position, we've seen the size, and just vectors from themselves. So we can do vector3 dot, and then we use new to create a new vector, where it constructs a new vector, and then just using those 3 numbers. We can also do from axis and from normal ID. Now, the difference between the small and the large written functions, I gotta be honest, I have not found. So what I'm assuming is that they're exactly the same. So we're just gonna use the one that is written small. And here it said, if we look at this again, we said that this is a enum.axis that we want. And so we can just type this, well, enum.axis, right? And then another dot, and then we can see we can choose the axis X, Y, or Z. So then we can just simply say, well, let's choose X. And this is going to be, so the X axis then, of course, represents 1, 0, 0. Because then we have a 1 in the X direction, 0 in the Y, and 0 in Z. And if we print this out, this is also what we are going to see. So if we print this out, what we're going to see is 1, 0, 0, exactly this. And then conversely, for example, if we do Y, the Y is then going to be 0, 1, 0. Let's just print this out. And as you can see, 0, 1, 0. And then Z is, of course, 0, 0, 1. So that happens if you do a vector from an axis. Now, there's also something that is a vector3 from a normal ID. Now, once again, this is something that you don't really need at this moment in time. I'm just going to show you, so because it's good to know. This is going to be an enum from the normal ID, and there we have some directions: back, bottom, front, left, and right, and top. So let's just do back, for example. Now this is basically a specific direction, and in this case, this is going to be 0, 0, 1. Right, as you can see up here at the top right in the window, we actually have these directions here. Back, we have we have right. Oh, we have front, left, top, and bottom. So those are directions that are already sort of predefined. And if we now print out the normal ID back, we're gonna get 0, 0, 1. This should be it. Let's see. Yep, 0, 0, 1. And in terms of this would be the back direction. And there are of course the other ones as well. So top is just 0, 1, 0. Front is then the opposite of back. So if we just do a front, for example, this is then going to be -1, because -1 is exactly the opposite direction of, well, I mean, if you negate one of the members of the vector, then it's immediately going to point in the other direction. So if you just times -1 or times -1, then you flip the vector around 180 degrees. Now this is of course all, let's say, theory covered already in the last lecture. If there's anything that's unclear about vectors, I definitely would advise to watch that again. Anyway, that is sort of the idea when it comes to vectors and the position. There are 2 more vector properties that we're going to see in future lectures. That is going to be the rotation velocity and the normal velocity. It's the rotation velocity and the velocity, because normal velocity would be something a little bit different. But yeah. Yeah, so this is basically all I wanted to tell you about vectors and position. And I hope you found it illuminating. If there are any questions, of course, always feel free to ask. I'll be sure to respond. And yeah.